Yeah, good afternoon again. So what I wanted to show in this presentation is a new development that we have been working on, and that's really to help to do execution error analysis on your BPMN and CMMN instances, but also to get more insight in general to what's really happening inside the engines while you are executing your process and case models. So looking at the current possibilities to do analysis or to really see what's happening in the execution is to look at the historic and runtime tables in Flowable. So for example, the activity instance tables for processes, plan item instance tables for the case engine, variables, execution data, and that's where you can really get your information from. In addition to that, of course, the logging information that Flowable produces, depending on the log level that you have set, of course. But that also really helps, definitely, if you set it to debug, then we produce quite a bit of information. And in the end, the final resort is always to do debugging, right? To do remote debugging against your engine and just step through and see what is really executing and what's really happening. But yeah, some of the error possibilities that your process or case can run into is, for example, a failing job. And a failing job is actually quite good in some way, because you know that the engine will automatically retry that job for you. So that it's failing one time and maybe running fine the second time is not always that interesting for you. The engine will just execute it the second time and everything will be fine. A more difficult one to get information about is a failing synchronous task. So if you have some synchronous service task behavior, which could already be at the start of your process instance or case instance, and you are executing that service task, then we automatically will roll back to the previous wait state, right? And that could even be before starting the process instance or case instance, because it could be, for example, the first service task that's going to be executed. So then, if it's that case, then you won't even have any information in the database because nothing is known about that process instance or case instance. So the only thing you have is the exception that you get while starting the process instance or case instance or while triggering the process. So that you can't resort back to the historic tables later on. The logging could help there, but there's no information on the later stage. And another one that is quite difficult to look into is, for example, setting a variable while there's also some other logic executing for that process instance or case instance, and you get an optimistic log exception, for example, which happens when something happens at the same time for the same instance. It can be setting a variable, can also be something else, of course. But those kind of things can happen in the execution. And the limitation of the historic tables is that you might not have all the data that you would like to have to do your analysis available, because you only know what's stored in that database, and you only know the full data. You don't know the exact order in which things have executed. And even worse, rollbacks are obviously not stored at all. So you have no information about rollbacks at all, right? You just can assume that something happened because you see an error in the log, but yeah, from the historic tables you don't see that. And another one, which is a more fine-grained thing, is that historic information is always the end of the transaction. Because how Flowable works is that we gather everything that we change within one transaction, and only at the end we will store that information in a database. So the data that is persisted in those historic tables will always be the aggregation of your transaction, which is fine in a lot of cases, right? Because you are only interested in the end result. You only want to know, oh, this path has been taken, these variables are currently set. But sometimes it's actually quite handy to know, oh yeah, this variable has now this value, but actually it was updated twice in that transaction. But you don't see that in the historic tables. You only see that, you only see the latest value. Or you need to set the history level to full, then you get some more information. But yeah, there are limitations in the historic table data. Just an example of something that could happen is a very simple process with a user task, HTTP task, and another user task. And let's say that HTTP task is an asynchronous HTTP task, and it has failed the first time. And for some reason, the second try works out. So we end up in the after task, user task as the state. But in the end, if you are running thousands of these instances, it might actually be quite handy to know, oh, there are 500 failures the first time to that HTTP task. And looking at the historic tables or any other data, you won't know that. You won't know that it has failed so many times. And in a straight-through example, so this is an example where we have a process instance with just 3 synchronous tasks that come after each other. And we start this process instance. Then if something fails in that third service task, nothing is stored at all in the database, right? So everything is rolled back, and in the database it will look like nothing has happened at all. And you will get an exception in the logging, but that's it. So what we have been working on is to add a feature we call the logging session. And what we did is we tied that logging session to the command context or transaction in the engine execution. So while stepping through the process execution, setting the variable, executing that flow element, executing that plan item, we log that all to this logging session. So you get a nice sequence there of everything that happened while doing the transaction. And we store generic information like the timestamp. We have a log sequence, so you have a nice ordering just from 1 to whatever number there is. Transaction identifier, so you can uniquely identify this transaction. A type, an event type, set variable, executed, activity behavior, whatever. And a message, just some informational message that helps a bit to read the event that has happened. In addition to that, we also always add scope definitions. So the process definition ID, key, and name, or the case definition ID, key, and name, so you always know the context in which this event is happening, and information about the instance. So the process instance ID, the case instance ID, that's also always present. And then each event can have additional data, like when you set a variable, it might be interesting to know what was the previous value non-existing, then you will only see the new value. But if there was already a value, then you will always also see the old value for that variable, for example. And in that way, for each variable, there could be additional data in that event. And we store that all in a JSON format, so it's really flexible what information is available there. And just as an example, so in the continue process operation, which is a class that helps to execute a process instance in the BPMN engine. Here you can see that we check if the logging session is enabled at the bottom. And so you can turn on and off this feature. And if it's enabled, then we add the type activity behavior execute to the logging session. And we put there which activity behavior is executed. And by passing also the execution, from the execution we can get the information, which process definition, which process instance, and all that. So that's all gathered automatically from that passing of the execution as well. And in that way, we have added on a lot of places this logging invocation, basically. We plan to add also more stuff to that, so it's only starting, but yeah, it all works in a similar kind of way. And then when we have gathered all these logging events, and we are at the end of the transaction, so the command context close or the close failure method is invoked, then we have an interface called logging listener, and that's something you can implement yourself. That will be invoked at the end of that transaction. Either if it has succeeded or failed, it will always be invoked, and then it is invoked with all the logging events that has happened in that transaction. And then you can do whatever you want with it, right? You can print it to the log. You can push it to another database. Yeah, that's basically up to your solution. So a very basic example, what we have is a simple output logger that puts the logging event in a specific format. So we always start with the process instance ID, for example, and we also add the execution ID if it's present. And in that way you can see an example of a very simple process where we started the process instance, then executed the start event, then took the sequence flow from the start event to the task. In the service task we were executing a class delegate, which was actually the service task logging test class, and then an inner class that we were using for that. You can see the beginning of that and the end, so you can actually also do some performance measurement if you are calling something outside of Flowable. So you know exactly this is where we started the execution of that class and this is where we ended. And then at the bottom the transaction was done, and we are closing the command context. So that's the kind of logging that is created in this logging session. And so that's available, and you can do you can add your own logic to that easily. But what is, I think, really makes it really valuable is if you can also put a visualization on top of that. So it's nice to have that list of log events, but to really visualize that with the model that you have, that makes it really usable, I think. So that's something that we call Flowable Insight, where we want to show a very early prototype where we are working towards for. So Flowable Insight will be part of the product offering of Flowable at some point. So this will not be made open source, but it's using the open source pluggability points that I just mentioned. So what we did is we implemented the logging listener that pushes all the log events to Elasticsearch, and then Flowable Insight works against Elasticsearch to be able to visualize everything in the tool. So I would like to show that in a short demo. So this is the starting page of Flowable Insight. So we have just two examples of what we are working on. One is failure detection that I want to show in a few minutes. And one is just looking at a specific instance. So you know the instance ID, for example, from the log, but you want to know exactly what has happened in that instance. So I know the process definition key that I want to look at. And then I want to look at the in-flight process instance. And what we use here is our regular diagram component where we can show the current state and completed activities for a running or completed process instance. But we added some additional stuff to it. So here at the top you can see a kind of timeline, and this timeline is actually the transactions that has happened for this specific process instance. So you know exactly which transactions have been executed as part of this process instance. So if we look at the first transaction, it's starting the process instance, then completing the start event and creating the user task, and that's where it stops. That's the wait state of that transaction. And there the transaction is completed. What we do is we show the elements that are part of the transaction in yellow in this diagram. And on the left-hand side, we can see some more detailed information of what has exactly happened in that transaction. So here we create the default variable initiator, so we know which person has started this process instance. But we also see a list of events. And this is really similar to the log file I just showed. So here you can see variable create was the variable create event was done, and it says variable initiator created. But you can also look at some more details. It doesn't really show well on the projector, but you can see here more information like which variable name, at which time, which variable type, which value, and if this was an update, if the event type would have been variable update, then you would also have seen here the old value of that variable. So you can see some additional data. Then the process started, the start event was executed, the sequence flow was taken to the user task, the user task behavior was executed, the user task is created, and the SNE of that user task, the default SNE is set, where you can also look again at which SNE value it has received, and then the command context was closed. And here we also show that the task order entry form has been created, and this is just a first step, right, to show the data that is involved in this transaction. And we can show a lot more data in the end as well, but this was the starting point. So if we now go to the next part of the transaction of this process instance, then you can see that the order entry form has a blue border. I don't know if it's you can see it that well, but it has a blue border, which means that it was completed in this transaction. Then this exclusive gateway was evaluated, and we went to the review order task. So now the review order task is created. And we have, again, a number of events as part of this transaction. So a couple more variables, because in the order entry form, some more variables were created, like product name, amount, and that kind of stuff. And instead of one task, we now have two tasks. And that continues in the further execution of this process instance. So in the third transaction, the review orders task was completed. We took another couple of exclusive gateways, and the timer event was reached. So at this point, the transaction stops again, because we are waiting for the timer event to fire, and that's where the transaction stops. So we can see similar information again, and know exactly what has happened in this step. If we skip to the end, then we can see that the timer event has fired, and the current state is process order. So this is now the active task for this process instance. And in blue, you can now see the path that has been followed. And maybe you also see that some of the sequence flows flowing out of the exclusive gateway are not blue. They should be blue. So that's one of the things we need to work on to improve that. We have that information, but it's visually not shown correctly right now. But this shows how you can really make use of all that logging information in a visual way and really step through the whole execution of the process instance while using the transaction slider. But if you don't know a specific process instance where you want to look into, maybe a more interesting entry point is the failure application. And the failure application shows a list of all the definitions, of all your definitions that are available on the engines that have a failure. So you could use this as a kind of entry point for detecting where failures has happened in your engine execution. So we have here a very simple example. For example here, it's a bit more complex, but let's look at this one, where we have that example of that I also showed in the slides of a user task, then an asynchronous service task, and then another user task. So if we go then to the instance level, so from there you can drill down. I didn't show that properly. So at the bottom you will see all the instances that have had this failure, and then you can drill down to the instance level. And then we can show again the same kind of visual representation of the process instance. And if we move a bit, so this has some more transactions, because what I did is I added a false expression to this service task, so it just fails 3 times and then the process stops. It will go to a wait state. So there are a lot more transactions here. But here you can see in which transaction the failure has happened. And you know exactly which events have been executed as part of that failure. So you can really look in detail what has happened. And at the end, instead of the command context close, you see command context close failure. So you know that something was rolled back at that point in time. What we also show here is, for example, the execution of the job executor. So here you can see that the service task was locked, and in the next transaction it will be picked up to be executed. So you can see quite low level stuff happening in this slider. Yeah, so now going back to the presentation. So really, what are the next steps that we want to work on? So we did a first implementation of event types for this logging session, but we want to add more event types to really make it fully complete. For example, we don't log yet that the job is moved to the dead letter job queue, which is quite important thing to know. So it's that kind of event types that we still need to add. And what we were thinking of is adding a possibility to enable and disable this logging, for example, via the REST API, so that you can really say, now I want to, in production, see the lowest level of everything that's happening. So I put on this logging feature, or I want to disable it. So what we are working on is to get this ready for the 6.5 release, so to add these additional event types and make it possible to enable and disable. And then it should be good to go for the first version. And later on also improve the features of Flowable inside, because this is of course just a simple prototype, but it shows a bit the direction of the thinking that we have, where we want to go to.